Hey everyone! In the previous video, we spent some time in order to set up this drone. We installed AutoPilot on the flight controller, and the primary reason to make sure that we can connect our companion computer to this flight controller using MAVLINK, because AutoPilot supports MAVLINK and it was designed to be operated by a companion computer as well. It's like probably a good idea. And last time we just looked at Mission Planner and we spent some time at Setup tab. There we tried to enable some serial ports. And as a reminder, I connected my companion computer to the flight controller using QART TX1 RX1 pins. So first QART. And it's exactly what we need to set up in Mission Planner first. And we did it last time. The only change that I'm going to apply now, I modified speed of this UART1 port. In case of AutoPilot, it's called serial port 2, but you can see that it's mapped to UART1. So I'm going to pick speed that you can see right now, 115/200. And potentially you can pick even better speed. You can pick even this one, yeah, but I prefer to leave it as is. And we need to make sure that UART1 enabled for MAVLINK version 2. It's the only thing that we need to do as for now in Mission Planner, so I'm going to return to Mission Planner back again. And what we are going to do next, once we connected our companion computer to the Matek, in this case, we are going to look at Ochin board documentation. If you go to the Ochin board portal, first of all, you will be able to see there we have UART pins. And you can see that we are using, for example, this video on our output. And next to it, we have two UART pins, RX0 and TX0 on this Ochin board. So you can use them, or you can use TX5 RX5 or TX4 RX4 that are on opposite side. So you can use the most cozy pins for you. Depends on how your board is located inside your drone. In our case, since I'm using on our output anyway, I prefer to use these two pins that connected to TX1 and RX1 once again on the Matek board. And if you connect everything and try to use MAVLINK, MAV SDK on your board, probably nothing will work. And you need to do something in order to set up your Ochin V2 board. What you have to do? First thing that I would recommend to look at hardware tests folder on this GitHub portal that is related to Ochin CM4 V2 board. And this folder contains several tests that Studio probably completed in order to validate the board. And one of the tests is related to UART. And if you open this test, you will be able to see what exactly you need to modify in your config.txt file. This file probably is a little bit not up to date at least. And now the right path to your config.txt, it's boot firmware config.txt. But you can see that you need to enable UART first. And enable UART set into 1. It's enable potentially everything what you have on the board. And after that, you probably need to specify GT overlay parameters with information about which exact UART you're going to use. So you can see UART 0, UART 4, UART 5. You can specify all of them at once. And one more parameter, DT overlay disable BT. It disables Bluetooth. And you can ask why I have to do this. I don't have Bluetooth on my CM4 board. And I don't have either. But there is a problem, there is a bug in Linux for Raspberry that just enable Bluetooth and connect it to UART 0, even if you don't have any Bluetooth module. So you need to disable it in order to make sure that it does not work your UART 0 here. And in case of UART 4, UART 5, you should not care much about this parameter. But in case of UART 0, you have to do this as well. So if I open Visual Studio Code, you can see that I connected to my Raspberry Pi board using SSH. I can do sudo nano And that path that I just mentioned, boot firmware, and config txt. Oh, I missed slash. Okay. And you can see that I already enabled all these parameters. So I just moved them as is. Enable UART equal 1, disable Bluetooth, and overlay for all 3 available UARTs. And after that, you can potentially connect to any of them. And additional parameters that I just enabled in this config file. First of all, we're using a digital camera, camera version 3 from Raspberry, and it just use IMX708 sensor. And I specify the camera port, in this case CSI 0, because in my case I have quadrocopter and CSI 1 is not located in the best position on Ochin board. So I'm using CSI 0, but potentially you can enable even 2 cameras and attach have 2 DT overlays here. And I am using analog output since I'm using analog video that I transmit from this drone, analog transmitter VTX, and it means that I need to enable analog output pin. I'm using enable TV out equal 1, and another parameter can specify what kind of video format you're going to support, NTSC or PAL, for example. Probably I needed to set up PAL, but as for now you can see it's NTSC. And that's all. All other parameters are by default. So I did not modify anything, and even for camera, some people and documentation tells so disable auto detect camera. It doesn't change anything, frankly speaking. So you can use Control O in order to save your file, or you can use Control X in order to leave the editor. And once you complete these modifications, you can restart your Raspberry. Since I already did it, I'm not going to restart anything. And that's not all. The problem that potentially your serial 0 can be linked to a console output as well. So in order to check it, you can potentially go into CMD line file, and I missed CMD line. And you can potentially see if you have any kind of references to your serial 0 here. I already removed all serial 0 information, but you don't need to do it here because you need to remove, first of all, link to serial 0. After that, you need to stop the service and you need to disable the console service related to it. So my recommendation, use rasp config tool. You have to use sudo rasp config, and this tool will work even using SSH. And what we are going to do here, we are going to go into interface options, we are going to go into serial port, and there is a question, would you like to use serial in order to communicate using a shell, a console? We have to pick no, because if you pick yes, it will be locked again, and you will not be able to use your ART in order to communicate with MAVLINK. So we pick no, and after that, would you like to use serial port to communicate to a hardware? Yes, we have to pick yes, because we are going to use to communicate to our flight controller. And after that, you can click OK. This command potentially disable all the services and modify CMD line txt. And after that, okay, I would recommend to restart your Raspberry CM4 in this case. And we can go ahead and start testing if you already have MAVLINK SDK or not enabled, and we can just see if we can connect to our flight controller. Of course, we need to install MAVLINK SDK. In order to install MAVLINK SDK, for embedded systems like this and for companion computers on drones, we need to use MAVLINK SDK for C++ because it's a hard real-time system, or at least close, something close to hard real-time system, since we're using Linux there, and it's not perfect hard real-time operating system, but at least we are going to build a system that is as close as possible to hard real-time. So C++ is like probably the only language that you can use. If you use Python, you probably your drone will not fly for a long period of time. So how to install MAVLINK SDK? You can use just MAVLINK IO site in order to read all needed steps. And first step, you need to just download the package. You can execute wget command. The only thing that you need to modify the link to the right package. There is a link to releases, and if you open releases, you will be able to see that latest version for today. It's 3.10.2. 3.10.2, and in our case, we're using Raspberry. Raspberry is based on ARM CPU, that is a 64-bit CPU. That's why we are picking from the list this library. We are picking ARM 64.deb, and we obviously need to modify the link to wget tool. So if you click copy link, and let's leave it here, I will just show what you have to modify in that instruction. You need to modify these two components of the URL to make sure that it references the right library. Because in documentation, if you execute even this command on your Raspberry, it's for AMD64, it will not work because you don't have AMD on your Raspberry. And after that, you execute deep package command in order to install the library. Obviously, you need to modify name here. I already have this library on my computer, and if we execute ls, you will be able to see it there. So I already have this on my computer and I already execute deep package command. And that's all. It installs everything, but how to start developing something? My recommendation, check if you have MAVLINK. If your MAVLINK can help you to communicate to the flight controller MAV-SDK, and you just need to execute a very basic example. And next step in the instruction is how to clone MAV-SDK for C++. You can just go to Git and clone MAV-SDK itself, and it contains a bunch of examples. So clone MAVLINK, MAV-SDK, go to MAV-SDK folder, and after that, go into examples folder. I already did it. I already have MAV-SDK, so we can go to MAV-SDK folder, and we can go to examples. There are several examples. My recommendation, execute example that calls system.info. System.info does not do anything to your drone. It does not arm it, does not disarm it, just try to connect to your drone and get some basic system information. So that's why what I'm going to do, I'm going to go into system.info folder. And after that, 4 instructions that we can see in MAV SDK documentation. They displayed extractions for takeoff end-to-end application, but we are going to execute the same command for system.info. So cmake build, and after that, it creates all needed files and generate mail file, and after that, we can execute build command itself in order to generate our binary that we are going to execute. These 2 commands create a build folder on your computer inside system.info. So you can see where is the build. You can go inside into the build after that, and we can execute our system.info. So if you installed MAV-SDK correctly, you should be able to execute these 2 commands, and you should be able to see your system.info file that you can execute. So how we are going to do this? My recommendation, start with something basic like system.info. System.info. And it displays what kind of parameters you are going to pass to system.info. In our case, we are going to pass our serial port. By the way, we can use ls command in order to see all serial ports on our computer, but you can see that it's just like one serial port. But if we modify serial to TT by AMA, we'll be able to see more ports. So TT by AMA star, you can see that we have all UARTs enabled since we enabled them in our configuration file. And now let's pass a parameter to system info. So what we are going to do, serial, after that we are going to have 3/ according to this instruction and dev, and we can use tty ama 0, and we need to pass speed 115 200, and I hope okay. So we can see that it's connected, it's found a system, and inside it just reads some information. So flight software 462, in our case ArduPilot 462, and some additional information that is not so important as for now, but at least we know that we were able to get this information from our flight controller. At this point, you are able to start developing own software, and MAVLINK connectivity has been established. If you see timeout rather than this information, it means that something wrong. It means that probably you still have locked UART port, or you probably connected different cables, your cables to different pins. Probably check TX and RX once again, because you should connect RX to TX and TX to RX. It's very important in case of UART. And after that, everything should work. And of course, check speed. Speed should be the same. And that's all. Thank you so much.